Okay, good afternoon. So if you remember, we started this new lesson, solving systems of equations. I told you two methods. One was substitution method, the other one was addition method. Okay, now, so I told you two methods for solving systems. Do you remember the names? One of them, the first one, was called substitution method, which is the most general strategy to solve all kinds of systems, not the systems that you study at this level. But the second method mainly is suitable for solving these kinds of equations. Do you remember what was the name of these kinds of systems? No, that method is called the addition method, yes. But the addition method is useful for what kind of systems? There was a name for it. And I think you mentioned that. This represents what? If I draw the graph of this, it becomes a line. That's also a line. So these kinds of equations are called system of linear equations. So the addition method is usually suitable for solving only linear equations, but the substitution method is a generic method, and then you can use that and solve the problem. Okay, I don't want to teach anything new. Today we want to solve harder examples. I'm not saying these are harder examples. This is good for refreshing your memory, but then these examples are a little bit harder, so you have to be a little bit more creative as well. So I want to wait for you. I think 20 minutes is at most. I mean, let us wait 5 minutes, 5 minutes, and then I want to ask your opinion about these, and then we continue with harder examples today. I want to wait for you. I want to ask your opinion. If you want to solve it, of course, I don't force you to solve it in any way in the exam. That's up to you. But if you want to use substitution or addition, which one do you think is more suitable for this? Addition is better. It has less algebra involved. But of course, if you manage to do it using a substitution, that's also okay. Okay, please listen to me. I think some of you are confused. Let me review things a little bit. Let me solve this one to review. You see, I don't want to teach you to in a way that you memorize. You need to understand. System of equations, we have two equations and two unknowns. Listen, please. The general strategy is to get rid of one of the unknowns and then keep one of them. Don't block your head. You don't have to follow exactly everything I told you, but you need to have understanding what we are supposed to do. Here, I want to get rid of one of the variables by addition method. Addition method directly does not help me. Why? Because if I start adding them up, it becomes 12x and it becomes 2y. So both x and y will again survive. But then try to think. You want to get rid of the one of the variables. You might be able to, so you might have to multiply the equations, both of them. But is it possible to multiply one of the equations by an appropriate number and achieve the goal? Yes. What is that? 2. If I just multiply this by 2, if you insist to get rid of x first, then of course you have to multiply this by 5 and this by minus 5. Sorry, this by 5 and this by minus 7. And then, are you listening to me? Yes? Because then in that case, you have to multiply 5 by 16. So that's why I'm saying, look here, I am not saying that is wrong. It is not optimal. You have to find an easy way to do it. So for example, if I want to solve this myself, so what I will do, I will teach you the other way around so that you can also see that. So if I want to solve this myself, I just take this one and multiply it by 2 because it is enough. Why? Because if you multiply here, it becomes 14x. This becomes minus 4y. This becomes 2 times 16, which is 32. And then I don't even touch the second one. Yes? Because I achieved the goal. If I now add them, 4y and 4y are cancelled, and this becomes 19x. And on the right hand side, this and that becomes what? 38. So x becomes 38 over 19, which is 2. You see, I didn't need any calculators. And when x is 2, I need to find y. I will come to your question. Then I go back to one of these original equations. No matter which one you choose, I will choose the one with the smaller values. So let me choose, for example, the second one. I put 2 instead of x, so it becomes 10. And then 4y is equal to 6. I move 10 to the other side, so 4y is minus 4, so y is minus 1. And then what I expect you to write as the answer, how many answers I got? Don't say 2. One answer. A pair of answer is just one answer. So x is 2, y is minus 1. You see, it doesn't mean that this is the only way to solve the problem, but I would say this is the optimal way. Some of you might insist to eliminate x first. Then, of course, you will be a little bit in trouble. Why? So let me do that because I don't want you to memorize. I don't want you to follow me without understanding. So you see here, if I write 7x minus 2y is equal to 16, and I write 5x plus 4y equals to 6, if you decide, not optimally, to get rid of x first, you can, and the problem will be fine. But it becomes a little bit harder. If I insist to get rid of x, what should I do now? For example, I multiply this by 5, make it 35, multiply this by minus 7, make it minus 35. Yes, okay, so I have to multiply this now. You see, it becomes 35x, and then it becomes minus 10y, then the number is bigger. But if you manage to do that, that's also okay. 5 times 16 is 80, yes? And then if I multiply minus 7 here, it becomes minus 35x. It becomes minus 21, 28y. And minus 7 times 6 is minus 42. You see, I have to deal with bigger numbers. And if I add them now, this time x is gone. But minus 10y minus 28y becomes minus 38y. The right-hand side, 80 minus 42 is 38. And then you divide by minus 38, you again get minus 1, which is exactly the same answer as before, but then you have to deal with bigger numbers. So don't immediately blindly start to do the calculations. Think a little bit, try to find the optimal way, and then do it. Okay, when I found y, I go back here. For example, I can choose this one or I can choose this one. Let me choose this one. I can even choose these ones, but that is insane. Because why should I bother with bigger numbers? I put back minus 1 here, so this becomes 7x. Minus 2 times minus 1 is 2, is 16. I move this to the other side, it becomes 14. And then I divide by 7, it becomes 2. And you see the answer that I get is exactly the same. I don't want you to memorize, so don't close your brain. Yes? Of course it works if you do it in that way, but then you have to work with bigger numbers. Why should we do that? So before starting, try to think. For example, if you understood what I said, of course here, if you go in this problem, multiply this by 10, multiply this by minus 15, it works. But minus 10 and 15 are not the optimal numbers. The goal is to make them equal. One way to make them equal and opposite is to multiply this by 10, this by minus 15. This is one way, but not the optimal way. Before starting, think about it. Okay, Hasbullah, do you have questions?
They're simplified 38 over 19. But if I have an answer, do I have to simplify it?
No, if the answer is a very friendly number like 2, yes. Otherwise, you have to leave it. I mean, if that is minus, if it is 38 divided by 20, I simplify by 2, it becomes 19 over 10. Then I can stop. But you have to simplify. Yes. Yes? So when I found this answer, I need to find the other one. I found x first, I need to find y. That is up to me. I choose one of these equations to put x in. I chose this one, which was simpler. I put 2, 5 times 2, 10, 4y, 6, then I move this and solve. Okay, so now you understand, don't close your mind. The strategy is to get rid of one variable at a time. Addition method and substitution method are methods to do this, but do them optimally. If you don't do them optimally and you manage, of course it will work and you will get the full points, but why you should make life hard for yourself? Just try to think first to make it optimal. Okay, so let us see that. I hope that everyone now found the optimal way. You see, some of you have chosen 7, 11 here, minus 7 here. That is correct. It will work. Some of you found 10 here, minus 15 here. That is correct. It will work. But that is not the optimal way. The optimal way is what? Listen to me, please. So what is the optimal way? Yes, I will take the system. So let me write it here. I don't know where is my blue pen. So 15x plus 7y is equal to 8. 10x plus 11y is equal to minus 1. So you see there is a better number here. If you target 30, then you have to multiply by much smaller numbers. Yes? So for example, I multiply this by 2, I multiply this by minus 3, and I am done. Why? Because if I multiply this by 2, it becomes 30x plus 14y. Be quiet, please. Hello. This becomes 16. And then this becomes minus 30x minus 33y is plus 3. I multiply this by minus 3, this by 2. Then I achieve the goal because my goal was to make them opposite. I did. So when I add them, they are gone. This one and that one is how much? Minus 19y. And this is positive 19. So y becomes minus 1. When y is found, I go back to one of the original equations with the smaller numbers in it. Here, 15x. This is not g, this is y. So, 15x, 7y is minus 7 is equal to 8. I move to the other side, so 15x becomes 15, and x becomes 1. So the answer that you are supposed to write is x equals to 1 and y equals to minus 1. And that's the answer. Okay? Is that clear? Okay, before moving on, I want to make sure that you can do it on GeoGebra as well. So let us try to do that. So I want to tell you how to do it in GeoGebra systems. I want you to learn this because it would be very important, especially for the next year. So you start with the word solve, okay? But the system of equations should be written in a pair of curly brackets. Be careful. And then you type the equations. For example, the same equation I just solved. I would say 15x plus, how many y's? 7y's. 7y's equals to what? Equals to 8. And then you separate it with a comma. Don't say what is GeoGebra is saying right now. Just type in. But you have to put it in the curly brackets. And then you have 10x, yes, plus 11y, thank you, is equal to what? Minus 1. And then you get your answer here. Okay? Yes. What? Yes, I will show. Okay, so this is the way of solving it exactly. But I want you to also learn, I will talk about this more later, but for the time being, let us solve the problem graphically. Okay? It is important. How can you tell me how can I solve this graphically? Let us say that I do not give you access to the whole GeoGebra. I only give you access to the graphical tool in GeoGebra. By the way, there is another application that I can use on exam.net, and that is called Desmos, or something pronunciation like this. it only has this graphical tools. So it is important to understand that I can give you only access to that, so that you can solve only using graphical tool. Okay, so how can I solve this using graphical tool? I asked GeoGebra to draw the graph of this function. It is, yeah, you can say function. And I can ask the GeoGebra to draw the graph of this one. So what do you expect for the graph of this? We had it in Math 1C. It's a straight line. That's also a straight line. But how can I solve the system using graphical tool? Yes? Yes, I find the intersection point. And the intersection point, the x coordinate is the x value, and the y coordinate is the y value. So let us just do it now here. Okay, so what I will do, I will type that equation in GeoGebra. So the equation is that 15x plus what? Plus 7y equals to 8. And I just press enter. And as you see, it is a line here. And I type the second equation. The second equation is 10x plus 11y equals to minus 1. Yes? And I have another equation. So if you don't mind, let me change the color of this one. I will show you a better picture now immediately. So let me just go to the colors and then, for example, choose that one. And then let us get rid of this part and make it more clear to you. Of course, these two lines intersect at a grid point. And then you see that the x coordinate is 1, y coordinate is minus 1. But if I give you access to GeoGebra, I will be able to ask you harder questions, not exactly on the grid point. So what you should do, be careful. You go to the points, there is called intersect, and now this is a syntax. So you choose that one and then click here and click there. It gives you the points. Even if the points are not grid points that you cannot read from the grids, then you can find them here. Okay? So graphically, it's a very powerful tool if you want to solve any kind of systems, not only these simple ones. You have to draw all the graphs of all the equations. In the simplest case, they are straight lines. But I can give you harder questions because you are not doing it yourself. GeoGebra is doing it for you. So I can give you harder equations and I ask you to solve them graphically. We will do that, some of them today or the next lesson. But then this is important to understand that you have to use this syntax of intersect, because not all the intersection points are friendly points that you can immediately read the coordinates. So you have to have a syntax to use that. You have a command to use this. Okay, so now let us go back here to the next problem. I hope that you understood everything. So this is E-level questions. This is a very standard problem, and then you should be able to solve it. But then, as usual, it is interesting to be more creative. So I'm increasing the level of the difficulty. So what do you think it is a good idea to solve this? I hope that you see this equation in the form is different from this standard and simple ones that you can see on the board. But what do you think I will do? Yes?
Multiply the first one with 5 and then the second one with
14.
14.
How is that reasonable for everyone? Because he is following one rule. If you have a fraction in an equation, it is better to get rid of those fractions as soon as possible. So this is a generic rule, because working with fractions, especially if we do not have calculator available, is not that easy task for us to do. So the best thing is to get rid of the fractions. So let me solve this one. For this one, I would say this is a C level, second level question. E level question, C level question, but I will consider this A level question, because this form is different, okay? So, what we do, the first thing we do, we just take this one and multiply everything by 5, because my goal is to get rid of the denominator 5. So let me just do that. I multiply this by 5. I multiply this by 5. I also multiply the whole expression by 5. But the 5 that I multiply will cancel this 5. Yes? And then the second one, I multiply everything by 14. This multiplied by 14. This multiplied by 14 is how much?
Which one?
14 times 3? 42. And then on the right side, I have 15 minus 9y. Because the 14 that I multiply will cancel this 14, and nothing will be left. In the denominator, this will be left. But what is your next move? What do you think I will do now?
Have all the x and y's on y.
Yes, that is the standard, making it a standard. Yes, so I move 4x to the left. Let us do it in our head. What is the answer? 5x minus 4x is x. 5y is already there. Minus 3, I also leave it behind. The same idea here. 14x is already there. I move minus 9y to the other side. What will be the answer? It becomes positive 9y. I have 42 y's here. 51y. Oh, sorry, 51y. And then 15 is left there. Okay, so here you have to be careful, because if you don't do it properly, then you will be in trouble. I mean, what is the optimal one to do it here? Multiply by minus 14. There is no other options, so you have to live with it. Okay? I mean, I can make it harder by multiplying by 51 and minus 5, but minus 14 is probably the best one. So I multiply the first one by minus 14. And then this is it, simple. You might be a little bit in trouble here, but this level of problems are not that hard. You have 14 crowns multiplied by 5. How much you need to pay? Minus 70. It's not a big deal. And then you have minus 14 times minus 3. First of all, it becomes positive, and it becomes what? 42. The next one, I copy and paste. And then I start add them. I will add them because I want to use the addition method here. So these two are gone. 51 minus 70 is how much?
Minus 19.
Minus 19. Y is equal to this one plus that one? 57. So y is 57 divided by minus 19. And this is also, I have it in my memory. What is that? Minus 3. Yes? And now be careful here. I can in principle put it back in one of the original equations, but I don't want to make life harder for myself. Which one of these equations you see on the board is more suitable here? Yes, this one is the best one. So choose the best one. Okay? So I put minus 3 here. So this becomes x. I put minus 3 here, is minus 15, is equal to minus 3. So what is x? X is? Okay. For the next one. Then I don't know how many of you could solve this one. Okay, very good. What about others? Okay, Ismail, let me ask you. So what, explain the first step.
So first, you see minus 5 over 9 there. So I thought, let me make,
No, I am talking here.
Yeah, no. So you see minus 5 over y in the first equation.
Yes.
And 2 over y in the second equation. I was like, let's get them rid. So I multiplied the first one by 2 and the other one by 5. And then it was 14 over 8 over x minus 10 over y equals 7.
Okay, so you got rid of this y. Yes. Okay, because how many of you agree with him? Okay, so that's good. So I don't want to change your method. My intention was something else. I will make the harder one, and might be you will understand what I mean. So I will follow yours. Okay? So your method is completely okay here. But I want you to see that this is A-level question, because you do not have these kind of systems that the unknowns are in the denominator. Okay, so here what you said, so if you don't mind, let me start doing it here. You said that you want to multiply this by 2 and this by 5. Yes? So let us do that. If I multiply 2 here, what is the answer? 14 over x minus 10 over y. The other one is 50 because I multiplied everything by 2. I multiplied the denominator, sorry, not the denominator, the second one by 5. So 15 over x and then plus 10 over y is equal 5 times 19 is how much? 90. No, 95. Thank you. Okay, then what do? I add them. This one and that one are gone. Okay, now my question for you is that if you add them, what will be the answer? 29 over x. Is that understandable? Because 14 over x plus 15 over x, the denominators are the same, so I add the numerators. But if I add them, it becomes 29 over x. It's better to do it in your head. So it becomes 29 over x. And then this becomes how much? 140. Okay, now my question for you is that, what do I do here? Let us ask himself, yes.
So we can do butterfly method. We do one like that.
So, yes, you can give a 1 to this, and then say that this times that is equal to this times that. You said butterfly? So in American say that the product of means is equal to the product of extremes. Okay, but that's exactly what you said. So I would say 145x is equal to 29. Yes? And then what is x? Yes? So 145x is equal to 29, and then this becomes this number. But can I simplify this more?
Yeah. 1/5.
1?
1/5.
Yes, it is 1/5. Exactly. But you have to do it. Be careful. Don't leave it like this. So x is 1/5. But when x is 1/5, then what I'm supposed to do? I need to find y. What should I do for y? I have to take my x and put it in one of the equations which is more simpler. Which one you prefer? This one. So I would write 3 over x. X is 1/5. Yes? And then I have plus 2 over y is equal to 19. Okay, but how many of you can do this quickly in their head? 3 over 1 over 5. What's the answer? 15. Yes? Because 3 over 1 over 5 means 3 divided by 1 over 5. This means 3 multiplied by 5 over 1, which is 15. So that is 15 plus 2 over y is equal to 19. Then what happens? 2 over y is, I move 15 to the other side, is 4. And then what do you say? You say 4 times y is equal to 2. So y becomes 2 over 4. But 2 over 4 is not acceptable as the final answer. You write 1 over 2. That is your x, and that's your y. That's x, that's y. But let me tell you something else. I didn't, so you told me this, I followed yours. That's correct. If you write this, you will get the full points. But do you have any idea? There is something that we learned in a different context that can be also useful here, yes?
I thought about multiplying by x and y.
If you multiply by x and y in this problem, it becomes harder. Why? Because if you multiply by x and y, then on the right-hand side, you will have 25xy. It doesn't make the problem simpler. This is one of those cases that getting rid of fractions is not good. Because if you want to get rid of the fractions, as you said, I have to multiply by xy, then the right-hand side becomes 25xy, which is not standard at all. Okay.
Does it work if you do it to the power of -1 on both sides?
Yes, it works, but it is not very good. Still, you have to work with negative powers. No, I want to see how many of you can connect two ideas. One idea from a totally different perspective in a different lesson to the idea here. Yes?
Multiply by.
No, not multiply. There was a name I told you. Might be you have forgotten the name, but you can refer to something, yes?
Well, is it that least common denominator?
No. Least common denominator is for adding. And this is more or less what he said. If you take the common denominator and multiply, it will be equivalent to say what he said.
Auxiliary.
Yes. The method of auxiliary variables sometimes is also helpful. So that's what I'm saying, that when you learn something in one context, don't think that it's only there. The important thing is that you have to be able to connect the ideas into different contexts. So let us say that this method of auxiliary variable, can you solve it by method of auxiliary variable here? I am not saying that this is wrong, that is totally acceptable. But the method of auxiliary variable is very helpful here. I would say let 1 over x be called capital X, and 1 over y be called capital Y. These are arbitrary names. If you're comfortable writing capital X and Y, choose different two letters. Okay? Then what happens for my system? The system can be rewritten in a slightly different way. Instead of writing 7 over x, what can I write? I can write 7 capital X. Yes? And instead of writing minus 5 over y, I can write minus 5 capital Y is equal to 25. And this one becomes 3 capital X, and then plus 2y is equal to 19. What type of, this problem is A-level question, but now this problem suddenly becomes E-level question. Yes, because that is the type of the questions we had in part 1 and part 2. So you can immediately solve that problem. So I don't want to solve it for you here. You go and find capital X and Y, and when you found capital X and Y, put them here, find little x and little y. So the method of auxiliary variable is not what you learn is only working for that context. So you need to connect these ideas. I don't know how to teach, but I have to draw your attention to be aware of that. So the method of auxiliary variable can also be working here. Now let me give you a harder question that the method of auxiliary variable is really helpful, and I want to wait for it. Okay? So this is the system I want you to solve now. So number 4, everyone should be able to solve it, because method of auxiliary variable immediately changes a level 3 question to a level 1 question. And then you can solve the level 1 question easily, hopefully. So the system that I ask you to solve is this system. Let me write it like this. 12 over x minus 3 minus 5 over y plus 2. This becomes equal to 63. Okay, so if you want, you can use the calculator for this problem. I don't want to distract you with the multiplication and things like that. And then plus 15 over y plus 2 is equal to minus 13. I want to wait for you. So you see that this system is a little bit horrible. Okay? So the method of auxiliary variable, this is, I would say, an A-level question by method of auxiliary variable in a suitable way. You can immediately transform it into an E-level question. I want to wait for you. So let me now explain. Please do not talk. Hello? So what is the good auxiliary variable here? So let us say, if you are not comfortable with x and y, let me write capital A, for example. A is 1 over x minus 3. B is what? 1 over y plus 2. Yes? Okay, so here it becomes 12a minus 5b is equal to 63. And then this becomes 8a. This becomes plus 15b is equal to minus 13. So you see this becomes immediately E-level question. But I want to use addition method. Do you have the optimal way to do it?
Times the first one
By 3, the best one. So I multiply this by 3, that's enough. So this becomes 36a minus 15b, 189, if I multiply this by 3. And I don't need to multiply anything here. Then I add them. it becomes 44a. This is gone, and this becomes 176. Yes? Am I right? So a becomes 176 divided by 44. But don't leave it like this. Even if you don't know, for example, if this is divisible by 11, you can do it step by step. So you divide by 2. It becomes how many? 88. Am I right? Yes. And then you see you divide by 2 once more. Or 11. You divide by 11. It's clear. And then this becomes what? So it is what? 11. It is 4. I don't need to trouble. 88 over 22. So a is 4. A is 4. And then I put it, so I found a to be 4. I put it back in one of the smaller equations here. I would prefer to put here. So this becomes 32 plus 15b is equal to minus 13. I move 32 to the other side. It becomes minus 45. So b becomes minus 3. But this is not done yet because I didn't want to find capital A and capital Y. I wanted to find little x and little y. So what should I do? I would say A is 4, but A has this name. So 1 over x minus 3 is 4. Can you solve it simpler? I would say that 1 over 4 minus x, I can, of course I can multiply. Let us just do this simple thing. So 4 times x minus 12 is 1. I move this to the other side. It becomes 13. So x becomes 13 over 4. Yes? And then I say that, okay, b is minus 3. But what is my b? My b is 1 over y plus 2 is equal to minus 3. So I multiply. So minus 3y minus 6 is equal to 1. So minus 3y is equal to 7. So y is equal to minus 7 over. Yes? So this method of auxiliary variable, this is not my point to give you to remember these things. I want you to be conscious about why you missed. The method of auxiliary variable is also useful here. So this is the way that you have to teach yourself to be aware of your mistakes. Okay, intentionally I want to solve this by the graphical method because if I want to give you access to GeoGebra, I can design very hard questions that even I cannot solve myself without calculating. So if you want to solve this graphically, listen to me here. How should I do that graphically? Yes?
When you did it earlier, there with a equal to 4
Yes.
and 1 over x minus 3. What did you do with the 4?
So you remember this. Whenever you have a over b equals to c over d, as Ismail said, this is called butterfly.
Yes.
Something like that. A times d is always equal to b times c. So here 4, in my head I wrote it 4 over 1.
Okay.
Then I use this butterfly. Okay, so now let us go back here. This is important. Listen. I will type this equation. I don't even know myself what will be the equation. What would be the graph? It would be x minus 3 here. And then I go here, minus 5 over what? Y plus 2. And then equals to what? 63. The number is a little bit bad. Okay, so a very strange thing happens here. So you see, because I will fix it, of course. This graph is the graph of this function, or whatever it is. It consists of 2 branches. It is not 2 functions. It is one function whose graph is broken into 2 parts. Okay, now we go to the next one. The next equation is 8 over what? X minus 3. Can you read it for me, please? And then plus 15 over y plus 2 equals to minus 13. Yes? Okay, so let me change the color here. The color, I can change it, for example, to this, and then let me close. Okay. I don't know if GeoGebra is capable of doing it right now, but let us see. The reason that this is not a good one because it is being squeezed. I don't know why, but let me see. Anyway, you see, the intersection points are not that clear. So you cannot read it even if you have access to the graphing tool. Do you understand that? So the red ones, both of them together is the graph of this. And the black ones together is the graph of this. It has two branches, each one of them. So if I want to find that, so I go to intersect, and then I see where this is intersecting. So I click here and here. I get 1 point. Yes? And that point is exactly what we found. 3.25 and minus 2.33. So this is why it is extremely important to be able to use this command. Because if the intersection point is not a grid point, you cannot just read it while looking at it. So you have to be able to use the intersection command, intersect command. Okay, any questions? No? Okay, I will not teach anymore. I want you to start practicing for the quiz. The quiz is only chapter 1. Okay? So I have already written on Google Classroom which pages will be included. So let me end this video now. No questions? Thank you.